Factoring Polynomials Part 2. This is Objective 2.6, and it is a continuation of what we were doing when we were factoring polynomials in Part 1 2 lessons ago. Our only objective for today is to factor a polynomial when none of the other methods from Part 1 work. So we mentioned when we did our 2.4 lesson, excuse me, that there were certain methods we could use for factoring polynomials that were based on previous methods that we already knew from doing quadratics. And when those methods work, then we should use them. But those methods do not always work when trying to factor a polynomial. So we need to have another method in place for that situation. Now this method is a bit complicated. So really, we're not just going to have this method down pat in just today's lesson. This is actually going to be spread out over the next couple of lessons to make sure that you have time to really comprehend and absorb how this is going to work. So we're going to take this idea of factoring a polynomial when none of the other methods from Part 1 work, and we're really going to be spreading it out over the next couple of lessons. So we have something called the factor theorem. And the factor theorem simply states a polynomial f of x has a factor x minus k if and only if f of k equals 0. Now that may not make a lot of sense, but if we kind of pull this apart a little bit, we're saying that we have a polynomial. We want to have a factor that's in the form of x minus k, which right away should look familiar to you because that's the form of the divisor that we use with synthetic division. And so we're saying that we will actually have a factor of x minus k if and only if f of k equals 0. So if you go back to our division and our substitution with the synthetic, remember that the way we can find f of k is by using synthetic substitution, working it out, and seeing what the remainder is. And so we're saying if we get a k value, that when we do that we get 0 as the remainder, then we can say x minus k is going to be a factor. So kind of translating this theorem into something that maybe makes a little more sense, we're saying if you do synthetic division with a number k, and the remainder you get, that last number in the last row, is going to be 0, then you can say x minus k is a factor of the polynomial that you started with, that you were dividing. Okay? So how does that help us if we're trying to factor a polynomial like the one we have here? So we're saying that we want to factor the function 3x cubed minus 11x squared minus 6x plus 8, given that we know f of 4 equals 0. So based on the factor theorem that we just saw, if f of 4 equals 0, then that must mean that the k value we're talking about in this case is the 4. That also means that x minus 4 can be a factor. So we're being told here to use synthetic division to then find the other factors. Okay, so here's what that would look like. So we've got our coefficients, 3, negative 11, negative 6, and 8. We have our k value out in front, that's the 4. And now we're going to do synthetic division. So there's 3 that we bring down. Multiply that by the 4, we get 12. Add that column, and we get 1. Then we multiply to get 4. Add that column, we get negative 2. Multiply again to get negative 8, and add that column, and we've just confirmed that indeed we do get 0 as the answer for f of 4, or as the remainder if we're dividing by x minus 4. Now that should make sense, because even numerically, we say that a number is a factor of another number when it divides evenly, meaning we can divide it and it has no remainder. So the same thing happens with polynomials. If we're dividing things out using synthetic division or long division, doesn't matter, but we get a remainder of 0, then that means the divisor that we were using in the first place actually is a factor of the polynomial we started with. Okay? Now, that means that I can now rewrite my polynomial as two factors. The x minus 4 comes from using this k value of 4. The 3x squared plus x minus 2 comes from my resulting row right here. Remember that we're always going one less degree than what we started. So if I started with a third degree, then this is going to be a second degree. So I've got my 3x squared, my plus x, and my minus 2 as the other factor. Okay, it's like saying I'm taking the quotient from when I divide and I'm multiplying it by the divisor. So even numerically we do that. If I say 48 divided by 8, I know that goes evenly by 6 because I get a remainder of 0. Then I can say that 6 times 8 will give me the 48 that I started with. Both the 6 and the 8 can be said to be factors. So that's kind of what we're doing here at this particular step, is we're saying the x minus 4 that I had here can be multiplied by this 3x squared plus x minus 2, and both of those are factors. Okay? But now, I don't want to stop yet, because, hang on guys, sorry about this. Oh, boy, I really lost it that time, didn't I? Okay, there we go. Okay, so I don't want to stop at that point because I want to look at that 3x squared plus x minus 2, that quadratic, and see if I can factor it any more, which I can. I can factor 3x squared plus x minus 2 into 3x minus 2 and x plus 1. So when we're being asked to factor a polynomial, given a value of k, which will then give us one possible factor, we can set up our synthetic division and use the result we get to try to come up with other factors. And we are trying to get everything as factored as much as we possibly can, just like we were in part 1. And so if we get a quadratic that can be factored, we need to keep going. Now sometimes we get a quadratic that cannot be factored. And if that's the case, then you would be done. Your x minus 4 times 3x squared plus x minus 2. If you could not factor that, you would just leave it that way. Okay, but if you can factor it, you need to. And in this case, all we were being asked for was the factor. So we do not want to go any further than this at this moment. This is the answer we're looking for. Okay? Now, what if I now ask you to solve the equation where I take that 3x cubed minus 11x squared minus 6x plus 8, that polynomial we just worked with, and I set it equal to 0? Well, since we now know the factors of that polynomial from example 1, that's actually a very simple task. So we now know that 3x cubed minus 11x squared minus 6x plus 8 can be factored into x minus 4 times 3x minus 2 times x plus 1. So I'm going to replace the standard form polynomial with the factored form polynomial and set that equal to 0. And so now we can see, just like with our part 1, that I can use my zero product property, set each of my factors equal to 0, and discover our solutions, which will be that x could be 4, x could be 2/3, or x could be a -1. Those are the 3 possible solutions for this polynomial equation when it's actually set equal to 0 and you're asked to solve an equation. Okay? So why don't you give this a try? And this is how your problems will be worded in your practice. Each problem is going to have 2 parts, part A and part B. In part A, you'll be asked to factor the polynomial given that f of k equals 0. And then in part B, you'll be asked to solve the equation for f of x equal to 0. So notice here that you're being given the polynomial for the function, and then after that, you're being told what your k value should be for the problem. And this right here is telling you k should give you a 0 remainder. So if it doesn't, there's something wrong. Check it out. Okay? But this is telling you k should give you a 0 remainder. That means x minus k should be one of your factors, and you should be able to find the other factors from that. And then in part B, once you've established your factors in part A, then in part B, you can use your factors to set up an equation equal to 0 and come up with solutions. Okay? Go ahead and give this a try. Pause this video for just a moment. Answer the question that's on your Zaption to the right. And when you have all of that done and you're ready to check, you can come back to the video and we'll see how you did. All right, so in part A, we are just being asked for the factors. And we should end up with factors of, x minus 3. That comes from having the k of 3. And then we should also get x plus 2 and x plus 3. So when we do synthetic division with a k of 3, we end up with x squared plus 5x plus 6 as our result. That can be factored into x plus 2 and x plus 3. Okay, so that's the answer for part A. X minus 3 times x plus 2 times x plus 3. Then we use that in part B to set equal to 0 and get our solutions. So x could be positive 3, negative 2, or negative 3. All right, so that's all we're going to be doing in our practice for this lesson. I'm going to give you a particular k value, and you're going to use that to try to find other factors, other solutions using synthetic division. Okay? There's one problem toward the end, I think it's the last problem in your practice, that's a little bit tricky. But I want you to see if you can figure it out. Try it yourself first, and then look at the answer sheet and see if you got it right. Okay? If you have any questions on this, make sure you're looking for resources to help you answer those questions as you go. If you need to email me, don't be afraid to shoot off a quick email. I'll try to answer as quickly as I can. And make sure you check your answers on the Canvas when you are finished. I do have the check-ins posted now, so make sure that you're completing all of the check-ins before your next quiz. All right, that's it for lesson 2.6. We'll see you next time.